Hey, how's it going, everyone? Welcome to the stream. I'm about an hour late off my schedule, and the reason for that is I was going to be streaming an hour ago, but then I realized that our air conditioning unit died. There's like, looks like I have a leak or something, and there's like ice all over the pipes and stuff, and so it's like really hot in my house, at least upstairs. So anyway, try to take care of that. Not much I can do right now, but anyway, so that's pretty much why I'm starting a bit late. Anyway, so tonight's going to be my last stream for a couple of weeks. I'm actually taking a bit of time off to be with my family. We're going to vacation a bit. So yeah, after tonight, I think I'm not really sure when I'll get back. Like probably maybe 28th or 30th or something of so near the end of the month. Something like that. We'll see. So I'll be announcing it, but yeah, after tonight, a couple weeks of no streams. Anyway, so last stream we were working on Bedlam, and by the end of the stream we pretty much figured out why Bedlam was not working. After the stream, there was quite a lot of interesting interactions that occurred. There was a comment on the YouTube video of last stream by Malban, who makes the awesome IDE I was using, VIDE, vid, I don't know how to pronounce it. Anyway, so I was using that, and Malban posted that, yeah, like that I basically was on the right track, that yes, indeed, not that I was on the right track, that basically I had figured it out, that the problem was exactly what I had stated, that Bedlam really kind of only works on real hardware, a little bit kind of lucky. You know, it does something very wonky. I think I have something here about it. I broke it down even further than last stream. So, you know, the real problem with Bedlam is that you've got a call that it calls wait recal, which in turn, while it's waiting, it's doing the loop that it normally does to see when timer 2 interrupt raises its flag, like when it actually stores the bit in the via interrupt flags. When that occurs, there's an IRQ handler that runs, which in turn calls wait recal. So this is kind of bad, right? You've got a wait recal causing an interrupt, which calls wait recal, and then when that happens and this guy ends, the fact that the interrupt flag was set to high is lost. And when we get back here, it says, hey, you know, should we branch equal? And then you'll say yes, because I didn't see the flag raised when I executed bit A. And actually what Malban said is that I can actually reproduce this in his own emulator by turning off a feature which he calls you know, like what he called it, like something like enable accurate mode or accuracy mode or something. And what that comes down to is that when you execute an op like bit A, which depends on a via instruction like here, during the operation there are certain cycles that get executed, and it's during those cycles that if we were to update the via, we would actually see that the interrupt got raised, and then we would actually store the result as not equal. And then afterwards, even if we were to jump on the branch equals to the IRQ handler, when we would come back, this branch equal would fail, like we would not jump here because we're not equal, and we would proceed. So that's like the, you know, more accurate way of doing things, and that's not what I'm doing, right? What I'm doing, and what a lot of emulators do, is execute an instruction, get back the number of cycles it took, then update the via and other devices with that many cycles. But that's exactly what causes the problem for me. Now, in reality, you know, Bedlam is a very poor example of how to code a game. It should not have been done this way. They probably didn't even realize that this is what was happening, because it only really happens in a very tiny window. Like, there's this, like, you press start to play. It's after you've played once, and you come back to the title screen, you press start, and it's just this one time that it calls wait recal that causes this issue to occur. And on real hardware, it would not have happened, or if it happens, it kind of like works itself out because of the timing, because the via really is running at the same time as the CPU and not afterwards. And so it kind of like through a little bit of luck and the fact that it's actually happening at the same time, eventually it would break out of this loop and continue. And then once it enters the game, everything works fine because it doesn't do this again. But in emulation, where we have something that's very, what's the word I'm looking for? Like very predictable in terms of behavior, this happens 100% of the time. And so you have to kind of work with that. So, so there are different ways to fix this. One thing I tried, and it worked, but I don't want to keep it. I'll show it to you guys. Is, let me go back here to my code. Okay, so this is the hack that I put in, and this actually fixes the issue. So what I do is, before I'm about to execute any instruction, like the next instruction, I save the last program counter. The counter of the, basically the instruction we're going to execute is here. I check IRQ enabled, FIRQ enabled. I execute the instruction. And I guess actually I could have passed these two flags in, but whatever. And then afterwards I update the VIA. And then here's the hack. If we were not enabled before, but suddenly by updating the VIA we became enabled. Same thing for FIRQ, but I don't really care about that. But basically that's the key. If IRQ wasn't enabled when we ran this instruction, and now it has become enabled, this is the super nice hack here. I const cast, because I only have const ref access to this, so I const cast away constness on the program counter. I force it to what it was the last time we executed, and then I rerun that same instruction still with the old flags in. But the key here is that what we're trying to say is, if the instruction we just executed may have depended on the fact that the VIA changed the IRQ state, let's rerun that instruction. And in our specific case, if we go back to Bedlam, we're talking about the bit A instruction here. So we run this instruction the first time, and as far as it's concerned, the interrupt flag has not been raised. So it's going to say, it's going to set the 0 to high, so we're equal. But before we execute this, we update the VIA, and then during that execution, using the cycles from bit A, it says, oh, actually, IRQ just got enabled. And we notice that, so we rerun this instruction, and in this time, it'll say, oh, that flag has been enabled, and therefore 0 will be low. And then even though, and in fact, when we do that, it'll even at that moment execute the IRQ handler. But the point is, when we come back, branch if equal will fail, it won't be equal, and it will continue. So that's a huge hack. I definitely don't want to keep it, but it works. It was more of a proof of concept. I wanted to prove that this would fix the problem with my understanding. Let's see if is this the right? No, it's not the right. And I'll just show you that it actually works. Got Bedlam here. Water. Whoops. Just die. And die here. Die another time. And now we come back here, and now I say go. And we made it, you see? So that's basically what we've been trying to fix all this time. So this works, but it's definitely not a good strategy. For one, there's a lot of things that are wrong with this, apart from the const cast. I mean, I can definitely make this a little bit cleaner, right? I could add an instruction on this, I could add a function on the CPU that's execute last instruction, and then have the CPU remember its last PC and all that. But the problem with this is, first of all, this fires more often. It'll fire almost every single time. In fact, it'll fire every single time the IRQ goes from disabled to enabled. And re-executing the last instruction isn't actually always a safe thing to do, because there are some instructions that have side effects that re-executing them don't work. For example, if let's say I was doing an increment, right? And then it was to run this again, I would increment twice. So this is complete garbage. I cannot do it this way. So yeah, So this is not a solution. This is more of a proof of concept. Now, what would be the real solution? So actually, let me see if I can find this here. David Parrott, one of the people who watches, I think he's not able to watch me live, but he watches my videos on YouTube after they come out. He actually mentioned something that I thought, yeah, that makes a lot of sense. It's actually something I've seen or heard of before. Let me see if I can find. I think I took a note of it. Yeah, I started working out what I might do here. Yeah, here. So David Parrott. I'm gonna open this link here. So David, if you're watching this, thanks for your feedback. He says here, are you passing the elapsed cycle so far from a CPU instruction when you read from the memory bus, and if it goes to VIA, so that's my question actually. And then he says that's similar to what I do in my Game Boy emulator. CPU increments a global clock. Hardware syncs on a read or write. So actually, I'll read that again. So I asked this question to Malban. Are you passing the elapsed cycle so far from a CPU instruction when you read from the memory bus? And if it goes to VIA, you first advance it by that many cycles? Because this was the thought I was having when I was thinking, how do you fix this problem, right? And when I saw that Malban had this kind of cycle accurate mode, I figured maybe this is what he's doing. And actually Malban hasn't answered me, but David says that this is exactly what he's doing, or something similar. He has this concept of a global clock, and he basically syncs his hardware, like his other devices, on a read or write. And then he also says here, also syncing after an instruction as well, as not everything is touched. So he says, effectively, the CPU produces the cycles that are consumed by the other hardware. Exactly. So, and then I say, yeah, I mean, I do that, except only after the instruction is executed, not during. And then, yeah, And yes, and then I made this note that based on what Malban has said is that this might not only fix the issues that I have with Bedlam. So this would fix a bug with Bedlam, but it may also improve the accuracy of vector drawing. So there are instructions that talk directly to the VIA, that write values to registers, and it's possible that by doing this, I may, improve certain vector drawing stuff, like maybe we'll get vectors that are slightly shorter or slightly longer or something like that, because we're doing updates or syncing the VIA in between instructions or during an instruction rather than just afterwards. Okay, so yeah, so in thinking about that, I started thinking, all right, what can I do, to fix that? I started thinking of different designs here, and basically, so this here, I'm not going to do it, but what I ended up realizing is that most likely I can, there are multiple ways I can approach this. I can approach this by having something very specific in the CPU that does something like grabs the VIA and says, here, I want you to sync, But I find that that's not a really nice solution. It's not generic enough, and a lot of the code I wrote, a lot of this kind of core memory bus stuff that I wrote can be reused in other emulators. So I'm always thinking, there's a part of my emulator that's very Vectrex related, and then there's a part that's not. And I was wondering if I can do something that would serve me in future emulators, and also that kind of makes sense, So my thought is that what I could do is, since we would like to sync certain devices on a read or a write, why not build it into this concept that I have of a memory bus device, right? It's related to the memory bus. So, maybe eventually I won't call it a memory bus. That's one of the thoughts I had here, was that maybe I would replace the nomenclature and call it like a device bus, and just kind of make it even more generic. Then it's not just about memory, it's also about syncing, right? So that's more about having a clock, and the notion of a device having a clock and being able to sync to it could be built into this thing, and this becomes an iDevice. I have this written down here. I don't think I'll do it in my first pass, but maybe eventually, if we see how it works out. So the idea would be something along the lines of devices can do reads and writes, but they can also sync. And in that case, they would take a certain number of cycles to sync to, like this, you know. And in fact, I think I would actually have a no-op version here. I think I could do this here. Because I don't think, in fact, most of my devices will not have any kind of concept of syncing. What's the problem here? Okay. All right, so let's say we have a sync like this. And what else did I write here? Yeah, and then the idea is that memory devices, so each device I have this like device info, I have a pointer to the device itself, I have a range for the memory, because everything here was about, you know, when we do a read or a write, I want to figure out which device I want to read or write to. What we could also do is we can track, first of all, do we want to sync on this device, right? So like, you know, I don't know what to call this. I was trying to do different things. I was thinking about sync type, and then I was thinking of doing like none, read or write. But I think what I'm going to start with is just always sync on read or write. We'll just say, does this thing sync or not? And if it does, on read and write, we will sync it. So like kind of like a sync enabled, you know? So let's say sync enabled. And if that's true, this is like sync cycles. Something like that. And then what we do is when we connect a device, we say whether we want to sync or not. And I'll do that with an enumeration because I like to do this rather than using bools because I just find that it just reads a lot better. We'll start with that. Okay, so let's say we do this. So we just we just initialized the Boolean parameter in the device info. So here I don't mind storing it as a bool because it's got its name and everything. So I'll just transform this enum class into a bool here. Okay, so once we have that, now here's the thing, I want to try not to make this too expensive, and that's sort of my concern, and I'm going to see if I can do this correctly without causing too much cost. But we'll start with a very basic approach, and then we'll see about optimizing it. So now the idea would be that the CPU, which has access to the memory bus, right, will go and kind of like add cycles. I think that's what I called it. Add sync cycles or something. Yeah. So it's going to have to call this every time it increments its own cycle count. So we say add sync cycles, and then what I have to do here is normally I would go through all my devices that have sync enabled and increment its sync count, which kind of is expensive. But let's start with that anyway, and we'll see about making this much faster afterwards. If device sync enabled, then device dot sync cycles plus equals to cycles. Okay, so we just do this. In fact, this if it's technically I could almost just not put it, and but whatever. And I'll just put a little to do here. So let's say the CPU keeps calling this, right? Then at one point, what we want to do is we want to do something like, okay, let's do this as well. We're going to add a sync function. And what the sync is going to do is it's going to go through all the devices. And if device.sync enabled, we're going to call sync on the device. So device. Oh yeah, I didn't want to call this device. This should be device info, because I have a member called device here. Device, and we call sync, and then we pass it the number of sync cycles it needs to sync on. Whoops. And then we clear that. So this guy has gotten his chance to sync. Okay? And I'm going to do this device info dance over here. Okay, so with just this in place, we should have a way to actually I was thinking about how this may not work exactly as I'm hoping, but let me just take a look. If I go to the debugger here, yeah, because I have this thing about effective cycles here. Why do I do this again? Yeah, maybe I'll push this concept deeper instead of doing it here. Oh yeah, and there's also the problem of when I sync on the VIA right now, I actually pass it more than just cycles. I also pass it other contexts that it needs. Right. So not so simple. Hey, Sonu Lohani. Why do you like dark theme more than light theme? I've Google searched and most of the comments I've got is that dark themes are harder on the eyes. Really? That's kind of surprising. I would say quite the opposite, actually. I found it a lot easier on my eyes. I used to use a light theme because Visual Studio came with that by default. And what I found over time was that... Oh hey, thanks for the follow, by the way. I found that actually, eventually I would like change my window. This was like back in like Windows 7 or whatever days. I would go and change the Windows theme to make the white, default white color of the background images of most Windows. I would turn them into some kind of gray because I did find the white hard on my eyes. And then actually when they came out with the dark theme, I was actually really happy about it because I find it really a lot easier on the eyes. So I'm surprised that you found that. I don't know. I have no problem with this personally. Have you found it to be different for yourself? So what will I do? The solarized theme, or in Visual Studio, or do you mean just like in general, like in Windows? The idea that as we go into nighttime, it removes blues and makes it things more like reds, so that we don't get the what do you call it there? That it doesn't mess up your circadian rhythm as nighttime comes. Is that what you're referring to? I don't know how I'm going to do this now. Because I'm looking at it and I'm thinking, this sucks, right? Because it sucks to have this one function that doesn't take in inputs. Because I need to pass in more than just the number of cycles. It is important that I get the input for this frame, the render context and audio context that I pass in for this frame, so that the VIA can go ahead and update those correctly. And I don't really want to set pointers to these things because these are not constants, right? These are things that get created every frame on the stack or whatever. I don't really want to store state, but if I don't do that, then I can't really have the VIA update the way it does, or I can't have it sync. Unless I split the two. Because actually it's true that a lot of this here, let me see. But there is the render context, and that's passed to the screen here. Yeah, that's not too cool. Yeah, I don't know. It can be so many things, you know. I've found like it could be the quality of the monitor. Sometimes it's even the connection, right? It could be like the cable that's been used, whether it's a proper HDMI connection or sometimes they'll connect monitors with really older monitors with VGA to HDMI, and then that actually causes some flicker if the analog to digital signal isn't clean. It could be refresh rate. There's like a number of things that can make it go wrong. So yeah, I don't know what to tell you. Like this, you'd have to take a look at all these things, you know. Yeah, there's not a really clean way of doing this, unfortunately. Oops. I think the only way we could, and it's going to be gross. Basically, is to have some kind of function like a set sync context or something like that, where we pass in. We have to call this like every frame, and we'd have to pass this stuff in, you know. Yeah, actually, you know what, Sonu, I'll call you Sonu if you don't mind, or Sonu. I agree with you. There is a difference in the font rendering. between the two, and I'm not quite sure what it is. Like now I'm at 120. This is 100%. This one I don't know where I'm at right now. They're not. It's not exactly the same in Visual Studio. You're absolutely right about that. But I use Consolas, which is I think the default now. Lohani is your surname? Okay, so I'll call you Sonu. One thing that can help in Windows is to go and set up your clear text stuff. If you like write in your Windows bar, your search bar, adjust clear type text or something, you should turn it on and then go through the process of actually saying which monitor you're adjusting, and then like start tweaking, like click the sample that looks best to you, and it'll have like a bunch of questions like that, and eventually you know, based on your choice, whatever you prefer, it'll adjust the way it does the, like some kind of anti-aliasing. And that applies to Windows in general, but there may be a difference between the way Visual Studio handles font rendering versus VS Code. I don't think you're wrong about that. I have noticed that VS Code seems to render fonts nicer. So I don't really know though what the details are. This is still good enough for me, and since I run at 120 for the stream, I don't really have any problems with it. But yeah. So yeah, I'm gonna have to like do something really crappy, like, you know. It's exactly what I said I didn't want to do. Let's say I did something like this, and then we would have a sync function, right? And actually this is an override, which takes in cycles. Virtual void sync, okay. And then right now I'll just make a call update with those cycles, followed by the sync context input. Not like that. Like that, but dereferenced. Right. Yeah, I don't know. If you ever find out what's going on with Visual Studio's font rendering, I'd like to know, because it's true that it's not perfect. I definitely noticed some weirdness about it, but not enough to annoy me when I'm working. You know what I mean? Okay, so this means that I'd have to do some, it's really crap, okay? Like, let's just be clear, I don't like this. But let me undo this crap I did here. But I'd have to start with like via set sync context and give it the input render context and audio context that I was giving it here. And then here, instead of doing this, we should be able to just say, in fact, we shouldn't do that. We should be doing memory bus. I have access to the memory bus. Yeah, Why isn't this working? So instead of explicitly calling the via like this, we first set up the via sync context, then we update the CPU, and then when we're done, we sync it here. This is post CPU sync. I do need to take care of the fact that the effective cycles here will be incorrect. I'm gonna put a to do here. To do for IRQ and instructions. Okay, to do in CPU, if no cycles have executed, we need to add cycles to, I'll just do this, memory bus, add cycles 10 so that other devices can do their thing while CPU waits. And in fact, if I don't do that now, Bedlam won't actually work. So I'm gonna have to do that. But just for now, let's say I do this. I do need to make this work. Okay, actually, let's do this. This is still a work in progress, right? I'll do one step at a time and just see if I broke anything. So if no, I'll do memory bus, add sync cycles. So for now, I'm gonna do the add sync cycles right on the outside and then sync. So this is effectively doing exactly what we were doing before. But what we'll do is this will move into the CPU. And every time we increment cycles, we're going to do this on the memory bus. And then when we do a read or a write, it will sync, and then that will advance the via by that much. So this should work as is. So let's see if that's the case. Oh yes, I need to fix all my connect devices here. Actually, via is going to be true. The RAM is going to be false. And I think that's everything. I missed one. Yeah, I missed one. Legal memory device will not sync. Right now, the only device that syncs, of course, is the via, and it probably will remain that way. The only exception is if I split out a couple of devices, because right now I have the via, which holds the screen, for example. And if I ever break the screen out as its own device, for instance, it might, you know. Okay, so this game will not work. That's expected because I did not. Oh, actually, is it expected? No, actually, it's not expected. Interesting how, so this is rendering correctly. Okay, so before I focus on this, let me just try Mindstorm. Okay, so this one works. So that's a good sign. Why would Bedlam not work, actually? I mean, I'm pretty sure it's related to the CWAI. Sonu, you're asking which other programming languages do you know? I know, like, do I know well? I mean, I know C++ quite well because I have been using it for like 20 years and I work in it daily. I can code in C alone, not C++. Not that I do it a lot. I know Python pretty well. I know F#. What else? C#, actually. I've done quite a lot of C#. Yeah, I'd say those are languages I really know. And then there's a bunch of other languages I've kind of played with. I played with Rust a little bit, still have a lot to learn in that. But yeah. Why do you ask? Oh, yeah, okay, I see why it's not working. Because of this. I have to actually add the effective cycles. This is what I was saying, is that if we get a CWAI instruction, we're going to be returning 0 cycles. And so if we don't actually advance the other devices, then we get stuck. And that's what was happening in Bedlam. So there you go. See, now this is working. Now I will not have fixed my problem just yet. All I've done is just move some stuff around. But the bug will still, prevail, as you'll see right now. See? So we're still reproducing that bug. Now the way to fix it would be to move this into the CPU. And that's what we're going to try and do right now. So I was looking at the way I handle cycles. It's not the best way. One thing that David Parrott was mentioning is that he breaks up the way he increments the cycles that should have elapsed into its constituents, into its parts during the CPU, which is like, oh, now I'm doing a memory read. All memory reads take this many cycles, and then so in the memory read function we'll add this many cycles. That's not how I did it, because so far how I've done it is I only care about the number of total cycles taken for a CPU instruction. It's a lot simpler to do it the way I'm doing here. I have very few places where I actually do a cycles plus equals, and the main thing is that we start by looking up the instruction we want to execute, and there's a base number of cycles for that instruction right here. So this comes from a table, which is right here. You see every instruction, the column over here, where you see like 6116, this is how many base cycles this instruction will take, okay? And then after that, there are extra cycles that can come in depending on certain things, and that's what I do with the rest of my CPUs. So if we look here, so this is one of the most complicated things, is when we do a read indexed EA. So this is like read indexed effective. This is for indexed mode. What I have to do here is I have to figure out, it's quite complex, I have to figure out based on the flags that are set in the immediate value for the indexed mode, which type of indexed operation we're doing, and then based on that, we actually add extra cycles. So this is a little bit more complex. If I look at this, it doesn't really matter because I don't think we do any reads in here except over there. So there is this here, kind of unfortunate, we do a read here. So what we might want to do to fix this is we might want to do this above the read. So you know C++ pretty well, followed by C#, Java, Python. You're looking into Rust. Yeah. Oh yes. Yeah, I follow Musian. In fact, he hosts me. Yes. Oh, that's how you. Okay, exactly. Oh, thank you very much, Sonu, for saying you like this channel. Yeah, so I've noticed that he codes in Rust, and I find Rust to be a very, very interesting language, so definitely worth looking into. So yeah, what I was thinking here is, you know, if we're going to do a read at this point, we're going to want to do maybe something more like this. we do this, and yeah, I might actually change all of this to just do a plus equals rather than compute extra cycles like I'm doing. You know, like take this off. It will simplify. I think it's gonna make things a lot better. So we go like everywhere I have this, we just replace this with plus equals. Right? And then same thing here. Whoops. Now here I'm doing plus equals 3 because this read is going to take 3 more cycles. This is totally not the right way. I just want to be clear. Like up here it's okay because we're not doing any reads, but here, like for example, this read and then this read and this combine, I think each one of these reads takes a cycle, I suppose, and then this takes a cycle. I don't know. I don't know why it's plus equals 3 here. I'd have to take a look at it more deeply. But you know, maybe it's good enough, and like I'll have like as a to-do to improve the way I do things. Like maybe I will push down into the read itself, the adding of cycles for the reads. You know what I mean? Oh, actually I am doing reads here. What am I saying? Yeah, I'm doing all kinds of reads. Yeah, I probably should do it the right way. So certain operations here don't do any reads. Certain ones do. So, I mean, for now I'm going to leave it like this, and we'll worry about it later. RTI, yeah, that's okay. Really, it only is going to matter if there's a read or a write. So use C++ at work? Yeah, same here. See all of these reads here, of course. Read relative offset. These here take cycles. And I put the cycles afterwards, right? Because, you know, who cares, right? For what I'm doing. But I'm probably going to want to push it down and try and do something a bit more accurate. I think what I'm going to want to do is subtract the, you know, like figure out how many cycles does a read really take, which I think is probably fixed and easy to figure out. And then everywhere where I have a plus equals, I'm going to have to subtract that amount from what I'm doing right now. And then that should mostly work out. But I don't think we're going to suffer too much with what I've got here. It's because, in fact, the reason why I don't think it's a big deal is I think the base number of cycles will account for enough to, like, hopefully it'll be enough to catch the, how can I say? The base number of cycles is probably like 80 to 90%, or, you know, 80 to 100% of the actual cycles that will be taken for the instruction. So if we've already added that and then we sync, we will have covered about 80% of the current instruction by the time we sync. Okay? So if there's a read, we will advance the via by, say, 80% of the cycles at worst. That's like, I'm just kind of guessing here. And hopefully that's enough to give us the accuracy we need. So in the case of Bedlam, hopefully that's enough cycles to figure out that the interrupt enable flag has been set. If I'm wrong, you know, if we need a few more cycles, then I will have to go in here and make it as accurate as possible. Just one recommendation, try using, you do know that this is a mechanical that I'm using, this weird split keyboard. Maybe you don't know, but I definitely agree. I definitely love typing on a mechanical keyboard. Okay, so let's say this is good. So now what we're gonna do is we're gonna actually change all of these functions that do m cycles plus equals into a function. replace all of these with that. Let's capture the numbers. Alright, Sonu, well, thanks for watching, and hope to see you next time. Take it easy, man. Oh, gotta put the regex on. That did not work. Why not? Like that. Little regex, and we get ourselves all these add cycles. Great, so now we've done that. What we want to do here is, I'm going to keep it like this, and I'm going to do a memory bus, add sync cycles. Maybe I should have like a reset cycles or something. This way I'm not dealing with cycles directly. Oh, looks like I missed these. How did I miss these? What's wrong with my regex? Strange. Okay, so I have this one here I need to change. Add cycles. Alright, it's not a number. Okay. And these ones. Oh yeah, I see why. Okay, so let's say add cycles. Same thing here. Okay. So now, if this is done correctly, oh, and I gotta go into read and write. So let me just make sure this still works. Oh, and I gotta, oh, yes. Hold on a second. It's not gonna work at all. I gotta go back to debugger here and remove this add. So now the CPU's execute will add, and we just need to sync. This should work as before with the bug. Just want to make sure that this works. Oh, and yes, of course, I need to do the the special casing in here. So let's see. Yeah. I think what I'm going to do is something like this. Yeah, this is kind of a hack though, isn't it? What should I be returning here? Do I return the effective? Maybe I should return the effective. Actually, then if I do this, I don't really need to do return cycles, right? I could just check how many cycles have elapsed. Maybe that would be cleaner. Yeah, and see, then I have, these are kind of weird hacks, right? So this read actually would elapse some cycles. But right now I'm not returning how many cycles from this read because it's been built into the CWAI's total cycle from the table. So that includes the read cycles, you know? So that's the kind of weirdness, right? Where it's, yeah, it's not quite accurate what we're doing. So I would need to fix all that. Actually, I guess I don't need to wait for that. It would still be wrong, but it would work. Now, the only difference though is that right now, if I don't return 0, for example, we don't know for a fact that we're returning 0. We just know that we don't know anything really. We just assume, like, it's kind of like, oh, by now, hopefully nothing has elapsed. But actually, maybe that's not so wrong. If we do change it so that reads elapsed cycles, this comment doesn't make sense anymore, and we really do want it to return the number of cycles. So, yeah, I'm all for fixing this. still add, we add an arbitrary amount. What did I write in the debugger here? I think I like lost my comment. Anyways, whatever. So we'll say if no cycles elapsed, add some arbitrary amount so that devices can advance and advance. So add nominal amounts of nominal. So that other devices can advance. Otherwise, we'll block forever. Okay, something like that. So let's see how this works out. We're almost there. Okay, so this is working. Looks like it's working. Let's fast forward and die, and the bug again should still be there because we have not yet fixed it. Okay, still there. And now is where we try to fix it. So the way we're going to fix it is we're going to go into our read functions. We have these read functions here. Read 16, and then read 8, and we have also, I think we have similar. Yeah, I think I've got like a bit of a, let me see how many functions I have that do like reads and writes to the memory bus. So I've got read 8, read 16, push 8, and pop 8, which deal with the stack pointer. Push 16. Yeah, some reads over here. Have a bunch of writes on the memory bus. So actually, yeah, actually I don't want to do it in there. So okay, we'll leave all that alone, and then what we'll do is, that's it, this is what I wanted to do. We want to go into the memory bus now, because that's where we put all our code, right? And we wanted to add the code in here. Okay, so here we go. So here what we're doing is we're doing a find device info, and then we're just immediately grabbing its device and doing a read. But before we do that, let's do this. Device info, if I can type, and we say if device info dot sync enabled, right? Here, let's add a sync device function. That's what sync will do. In fact, we'll also check if it has actual. Let me It says sync. We'll have find device info, sync device from a device info. So it'll be something like that. Heck, do I even want to bother checking if it's enabled? Now I think about it. Because if we're checking, like we can just do this. Maybe it'll be like a try sync device, you know? Do that. And then, what don't you like? Oh, because it's not const. Yeah, that's one thing, is that this is kind of like mutable crap, right? Yeah, this kind of changes the contract a little bit, right? Because now we're going to be modifying this data. This data has to be mutable for this to work. Okay, let's just see. Alright, and then we do device info, whoops, device info dot device read. And similarly for write, oops, do that, and device dot write. So basically on read and write, we always try to sync the device, but that basically will only do something if sync was enabled, because only if it was enabled would we have even added to the sync cycles. And since we're checking, yeah, I guess we may have to check here. Just check if sync cycles is greater than 0. So here I'm just going to do sync device. So something like that. Let's see. Alright, so this might take a hit on the frame rate because now we're doing these extra operations. Hopefully not too bad. I think most of it will get inlined and it's just mainly a check, except for the via. So we should see some hit here. Yeah, so I see my frame rate dropped a bit. It was normally like 140 and now we're like at 114 or something. So, or 120. So there is a hit. There's no doubt that this is going to be more expensive. That just goes without saying. And there is something I can do to make it a little bit faster. Although I'm not sure where the real cost is. And it works. So that's what I was hoping. I was hoping that this would be enough to fix it. It works. Let me try it again. See, it's working now. So, is it awesome? No. Because the part that I don't find awesome is the set sync context crap that I'm doing every frame. That's kind of crap. Splitting the having to store a pointer to the data as a data member so that it can read it later when it gets synced. It's kind of crappy. I'll try to think if there's a better way for me to do that, but I don't really see how else I could do it. let me just try a few other games. We'll try some of the more finicky games. What do I want to try? I'm curious if Spike changes at all in terms of rendering. Okay, this one looks pretty much the same. Let's try, oh yes, one that does do crazy rendering is Clean Sweep. I think that's, yeah, there's a couple of things that look a bit weird in this game, but I'd have to do like a before and after thing, which shouldn't be too hard actually. I'm curious. Yeah, so the thing I was saying I don't really like is this line right here. Like, I feel like I'm gonna have to do this in a few places if I were to have more devices, you know? But for now it'll probably just be the Via, so it's not too bad. Oh yeah, so now I'm gonna always say I've executed instructions. So let's change this a bit. Let's do this. We'll return to actual cycles executed, but we'll do this little hack internally so that devices can advance. Although now it's a bit weird, because it means that maybe what I want to do here is something like this. No cycles have elapsed. We're waiting for CLI. So add some sync cycles so that other devices can advance. Otherwise, we'll block forever. Alright, let's do the thing of making this void. It just becomes a void function, and we just do execute like this. And I'm starting to think, why am I doing any of this here? So let's remove the reset cycles and the cycles function. We'll just do that. We'll check if it's 0. Like this. I was returning effective cycles. I actually think I don't even use the return value, do I? Let me see. No, I don't even use it. You know, since I don't use it, maybe I shouldn't even bother returning it. Oh no, do I use it? Maybe I do it here. Oh, and I was returning effective. See, that's kind of weird. Shouldn't have been doing that. Ah, but if I don't return the effective, then I think we do get blocked here. That was the reason. Yeah. Hacks. What do I use this for? For nothing? It was just for me, wasn't it? I'm gonna remove this. Ah, yes. I do have dependencies for the trace info. So I do, what do I want to do here? Because now I've pushed my hack into the CPU here. Because this is where I'm dealing with adding sync cycles. Maybe I'll move this back out. Maybe this hack doesn't need to be in there. it's a bit garbage, but it's mostly more for my debugger. I need to know the actual CPU cycles that have elapsed here. And I have some stuff because it's possible that an exception gets thrown while we execute the instruction itself. And if that happens, we're going to get 0 CPU cycles. Or in this specific case, oh yeah, sorry, forget about the exception. It's really this. If the CPU didn't do anything waiting for interrupts, we have nothing to log or hash. This is for my logging stuff. And in that case, I need to know that no actual instruction, like nothing actually did happen in the CPU. So I want to keep the idea of real execution and actual CPU cycles elapsed in there. Okay, now there's like less and less reason to even have this function this way. But I think I'll keep it anyway. And yeah, and then basically this effective here is more about, well, it's got like 2 purposes. One of them is, well, the 2 purposes are related. So one of them is make sure we actually do more. Like if we have 0, let's put 10. We'll advance our memory bus by that much so that the VIA can do something. We also make sure to return it, because if we don't return, if we return a 0 amount of cycles, we'll end up in an infinite loop, because the whole idea on the outside here is we're going to basically try to consume and execute as many instructions as we can for the delta time of the frame. And so if I'm returning 0 here, we've elapsed nothing, and in that case, we're screwed. So actually I should put an assert here. This has to be greater than 0. Otherwise, yeah, so this has to return non-zero. So it's not pretty, this code, but it's the name of the game, right? The fact is that since we're driving other devices from the CPU, if the CPU has an instruction that just doesn't do anything, which is the case due to CWAI, and really it's just that instruction. Without that instruction, I'd have no hacks in here. It would just literally be, get how many cycles, return it. But because of CWAI, I have to put in all this special case crap in there. Such is life. I mean, I guess I could, in theory, make it so that the CPU pretends cycles have elapsed while it's waiting deep inside. I could do that. If I did do that, what would be the effects? The effects would be that that's it. One of the downsides to that is my trace would just be filled with CWAIs. So, perhaps the solution there is not to rely on the elapsed delta time, but rather to make my trace aware of CWAI and say, hey, if the last instruction was a CWAI and I've already logged it, then don't log consecutive CWAIs. I could do it that way, because I think that's really the only case I have. So I'll put a to-do about that here. We only do this because of CWAI. Instead, simplify this code along with the effective CPU cycles code below by just detecting if we're going to, and not re-adding consecutive CWAI instructions to the trace. Yeah, that would definitely be simpler. Why did it do that? In fact, I think I'll move this down here. Yeah, that would be much cleaner. Although I'll still have the problem. Well, I guess if I do that, will it change anything? Yeah, no, that'll work. Yeah, so what I'll do is by having CPU return 10 cycles while waiting for interrupts. From CWAI, and detecting and re-adding, and not re-adding to the trace. Yes, that's the right thing to do. And I'm even going to let me erase all this crap here. Okay, add more. Okay, so this is what we've been working on here. Clean up CWAIs and just not adding them to the trace. Okay. So let me see what this looks like. I'm gonna look at it a bit more deeply. Just give me a second here. Yes. So lots of little diffs, but that's all right because we changed a few things. Okay, let's go do a little bit of cleanup in there via. So we're gonna keep this garbage. I'm gonna move this down here. Maybe I'm a little bit higher up. Sync will be moved into private. We're gonna actually Move it to the CPP file. Move definition location. It's in the right place? Yeah. Good. Set sync context. I think I'll leave it in line for now. Update. We'll rename this one to do sync or something like that. And this will become private, as we will no longer call it publicly. I'm gonna leave it where it is. I don't really feel like having a huge diff for it, so it's alright. Read, write, sync, do sync. Yeah, I'm just gonna move that here, I suppose. Good. Take a look at memory bus. Yeah, what I was thinking about was how I would optimize this. I'm gonna leave it alone for now. I'll just add a little bit more. Optimize this so we don't loop through all devices every time we add cycles. So that's really the cost that we're trying to. I would love to avoid here. But the only way I can see doing that is something like we'd have like a local, you know, a count, our own like cycles counter to which we would increment, to which we would add cycles to. And then lazily we would transfer that into, we'd do this loop lazily, like on demand when trying to sync a device. You know, and in fact it would not be on syncing a device, it would be, yeah, exactly. Actually, it would be sync device. Sync device would have to do it. In here, it would say if the cached variable is non-zero, like we have cycles, not this if here, but like basically what I'm saying is, even though we're trying to sync a specific device, before we do that, we have to look at, do we have cycles that need to be transferred into the counters for all devices that are enabled lazily. So that's sort of what I'm getting at. And whether that actually helps or not will depend on the frequency that we call add sync cycles versus the frequency at which we actually sync. And it may not be worth it, actually, because we probably get reads and writes so often that it would be about the same cost in that point. So perhaps another thing we will do is just have a separate array. Instead of going through all devices, just have the devices for which sync is enabled. So that would probably be faster. We'd loop exactly through one device. And that's if this is actually costly. So I'll leave it to do because it might be the case. And if I ever see this function pop up on a profile, I'll look at this to do and go, oh yeah, right? If it doesn't, then whatever. I'll leave it alone. Look at this. I guess I should be clear here. I shouldn't say to consume elapsed CPU cycles because we may have already consumed them from reads and writes. So what I should say is sync all devices to consume any leftover That's good enough. Here I used to call it effective cycles. Huh. I think I'll leave it like this. Effective CPU cycles. Yeah, I was just thinking about how... Nah, it doesn't matter. Okay. Now actually, I don't really want to be here in Git. Let me just... I don't really need to do this, but just to be sure, I'm gonna stash this, bring it back, and where I really want to be is I would like to do this here. Git branch force master to head. Git checkout master. So we're here now. And I want to go back to, if I remove fail message, okay, I want to go here, reset here, but keep it mixed. Now because I didn't want these extra 2 commits from my hack. So now it's going to look a little bit different, in particular here in the debugger. Yeah, slightly cleaner than we had it before, because we don't have the, yes, there we go, it's much cleaner. So this is a real diff. We used to do execute instruction, and then update the via, and now we do set the sync context on the via, execute CPU instruction here, and then later on sync the memory bus, which will run the via. And we know the via runs now during the execution of instruction whenever it does a read or a write. Okay. So let's do a few more tests. First of all, let's build this, make sure it builds. And we'll run a couple of tests. I want to make sure that other games are working correctly. And if everything looks okay, we'll get this checked in. Oh yeah, I did want to make like an option for this feature. Maybe as a separate commit. Because it's definitely a big price we're paying for maybe not much gain. But I also want to try like toggling it on and off and seeing how it feels. You know, one thing I think I'm noticing already is the slant in here. I'm pretty sure we didn't have that slant. Or maybe I'm misremembering it. We'll check when we add the option toggle. This looks pretty good. Let's do a few more times. I just want to be really sure that this is fixing the bug. Alright. This looks all pretty good. I don't know what to test. Here, let's try vFrogger. I didn't even know there was music in this. Let me stop my music for a second. Very nice. So many cool homebrew games. There was a game that Malban mentioned that also he said it would have trouble with. Oh, it's not here. Let me see here. Let me try and get to my comments. Like basically, there's two parts to this. Yeah, I don't want to hear myself. Let's see. 3 comment. Where are the comments? Sometimes it's weird. Why can't I see my comments? CPU. 3 comments. All right, I don't know why I don't see them. Just give me a sec, see if I can find them. Oh, okay, here we go. See if I can find where he said it. Bedlam also has a same. Oh, okay, no, it wasn't another. Oh, yes. Okay, yeah. This is kind of fun. Yeah, here we go. So actually, I think I pointed this out before. The bug that I had that we just fixed with the cycle accurate, ParaJVE also suffered from the same bug. So I think almost anyone who writes a Vectrex emulator will have this bug at one point. And in fact, his fix at the time, and he may have fixed this correctly afterwards, but at the time he commented, and his fix was to do the thing that I had also discovered could work, but was not the correct fix. And basically it's, as he says here, he says it's according to the 6809 docs, it seems that the CWAI mask should be applied to the CC register before saving it onto the stack. But for some reason, it prevents Bedlam from working properly. The only game around that makes use of the CWAI instruction. Unless it becomes a problem with another game, it is likely to stay this way until I've got the time to check it out. And what he does is he says he actually explains the problem. He actually went as far as understanding it. And then he says the problem is that when the main loop gains control, a T2 timeout already occurred and the next IRQ is pending and handled since CC now has the I bit reset. Thus, the main loop code is never executed because the CPU is constantly executing the IRQ routine. Maybe the problem is not in the CPU emulation code, but in the VIA T2 handling and IRQ handling instead. So the point is that his fix, at least at the time that he wrote this comment, he says fix the bug in Bedlam, and he says the fix is temporary and need more investigation. So at the time, the way he did it was the way I had proposed to do it at first, which was to swap the order and make it so that we don't save the fact that interrupt mask is low and put that on the stack. But that is the incorrect fix. So maybe he ended up fixing it because this is quite a while ago, or maybe not, I don't know. So I just thought that was kind of fun to see, like, you know, there was yet another emulator author who had a similar problem. Let's try one more. Pole position. First gear, second gear. Cool. This is a cool game. All right, pretty satisfied with that. So let's get this committed. So what do we say? We say add clock sync for devices so that devices via can be updated on read write for more cycle accurate emulation. Fixes Bedlam. I'll put that here. Fixes the Bedlam lockup bug after game when starting a second game. This works because I feel like I need to put in my commit message what we just fixed. So let me see if I can. The Bedlam bug happens because of the following. What did I just do? I tried to copy paste some code. There we go. Just amend the commit here. This commit fixes the issue by making it so that when bit A executes, it will advance, will sync via upon reading from it, which ends up raising the via interrupt flag. And this is seen by bit A. So its result is so cc dot z will be low. After that, BEQ will even though the IRQ handler runs, when it returns, BEQ will not branch and continue as normal, will not branch and thus not start up the infinite loop, the loop again. Okay, I think that's clear enough. So I'm actually going to push this, and I'm going to make a to-do here, a little note. I'll say, because we did this, and I'll just say add option to toggle the sync on read write, more accurate emulation, and then I'll put here, see the effect it has on font rendering, line rendering, especially in games like Minesweep, etc. Okay. So that's pretty cool. I'm looking at the clock. It's midnight. I think I'm gonna stop here because it's late, and I'm very happy that this worked out. So yeah. So guys, thank you for watching. Thanks to my viewers, David Parrott, Pyro, for all the feedback. This looks like, and to Malban, of course, for his feedback. This has been quite the journey trying to fix Bedlam. We've done it. I think this is the right fix. I'm overall happy with it. There's this thing that I don't like too much. Like I said, some things just gotta kind of live with. If I think of a better way, I'll do it, but I doubt it. So yeah, so guys, thanks for watching, and I'll see you not next week, in about 3 weeks from now, I'd say. So next couple weeks will be off. But yeah, I'll be posting it on Twitter, so if you want to know, follow me on Twitter and I'll let you guys know. All right, take care.